Good afternoon, everyone. I'm audible.
Yes, you are audible.
So, hello everyone, dear authors and invited guests. Welcome to Technical Session 8B. I am Rajnandini Patil and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, Pune, India. The 10th edition of the conference is being organized in hybrid mode. The physical event is held today in Pune and the virtual event is being held through Zoom from 19th to 21st of January 2026. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minute, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce all to the chair for this session. That is Dr. Rachit Advaryu. Dr. Rachit Advaryu is an associate professor and program head at Department of Computer Science and Engineering at Mawadi University, Rajkot, India. He is actively engaged in teaching, academic leadership, and faculty development initiative, including conducting workshops such as ChatGPT sessions for educators. Dr. Advaryu is committed to shaping digital and professional skills in computer engineering and regularly shares departmental achievements and university activities through academic and professional platforms. Welcome to the session, sir.
Yeah, thank you very much. So let's proceed with the
Now let's
first
start with our
presentation.
first research paper. Yes, sir. For this, I would like to call Sonam Kumari for the paper
Yes.
title A Comparative Analysis of LSTM GRU and Ansible Models for Solana Cryptocurrency Value Forecasting. I kindly request the presenter to start with the presentation.
Yeah, wait a minute. I will be starting.
Yeah, you can share your screen now.
Good afternoon, everyone. I am Sonam Kumari, and today I will be presenting our research paper titled A Comparative Analysis LSTM, GRU, and Ensemble Models for Solana Cryptocurrency Value Forecasting. This work is done under Indira Gandhi Delhi Technical University for Women, along with my co-authors Sanjana Shubkrishna, Yashika Sagar, and guided by Dr. Ritesh Yaduvanshi. Before jumping into models and numbers, let me start with a very simple question. That is like, how many have you heard about crypto suddenly going up and suddenly crashing? The unpredictability is the core problem that we are trying to understand. As we all know that crypto markets move very fast. Prices don't change smoothly or like slowly. They jump, and sometimes it because of news, tweets, and pure hype cases. Now, the main issue is that traditional statistical models expect data to behave nicely, like they expect them to linear and reliable in straight lines. But crypto prices don't do that. They are non-linear and very much uh, chaotic type. So we are in this our solution was that we use deep learning models, specifically LSTM, long short-term memory, and GRU, gated current unit. So like just like humans don't forget yesterday's price when thinking about today, these models also learn from historical sequences. And we use Solana because it has a high transaction speed, low transaction cost, and it is the best stress test for our models. And coming to the next slide, that is literature review. Many researchers have already tried predicting crypto prices. Like they used SVM and random forest, but they performed well on linear data and struggled with the memory. And few also worked on LSTM and GRU, and but it increased the complexity. And most study was focused on Ethereum and Bitcoin. So Solana was underexplored. So we challenged ourselves to explore that Solana currency. So moving to the our proposed work, we had three major ideas. Firstly, we focused only on the single model to have the prediction accuracy better. And we applied some ideas. Firstly, we focused only on optimized version of that. And at last, the ensemble strategy. Because instead of trusting the single model to have the prediction, we use SMARTCOM and GRU to check the stability and accuracy. And we use that we applied logarithmic returns on that. Coming to the methodology that we have used. So we used Solana historical data from the Kaggle dataset of 2021 to 2024. So we applied some pre-processing techniques like handling the missing values, converting it to the uniform timestamps, and min-max scaling for the normalization so that it don't leak on to prevent the data leakage on the training data. Uh, and we applied feature engineering also. Like we use various features like open price, high, low, close, market capitalization, and use technical indicators also like moving average, relative strength index, and moving average convergence and divergence. So these features helps us to model to generalize better and perform the prediction accuracy well. And the model that we use is first is LSTM and GRU and then the weighted ensemble. And we use also naive baseline for setting up the benchmark for that. And in evaluation metrics, we used root mean squared error and mean absolute error and R square for the accuracy. And tools is Python, PyTorch, Pandas, NumPy, Matplotlib, and scikit-learn. So let's move to the experimental results. So in baseline, we used the 60-day look back period and used eight basic features. So as you can see in the graph that LSTM has the accuracy of 0.73 and GRU has the 0.916. So why GRU performed better in the baseline because GRU has the simpler architecture and we had the small data set. So GRU generalized and outperformed the LSTM in the baseline stage. Now, i- here you can see that the GRU, that green line is trailing that two price more closely than the LSTM model. Now let's move towards the second stage, that is optimized models. So in optimized models, we optimized we added various features. We took the 14 features and increased the look back window of 90 days. So what we see in that LSTM accuracy was jumped from 0.730 to 0.986. Okay, and then comes to the GRU. It is same as LSTM, and we applied the weighted ensemble, which is the combination of LSTM and GRU. Combining both the models, reduce the variance, and errors were mostly centered around zero. And there was a gap also. Like after optimization, the LSTM and GRU accuracy gap is also closed. Like we can see in the next slide, like error is mostly centered around zero. So model is precise and unbiased. And in this graph, we can see that according to for the first 200 points, true and the predictions is closely. And let's so to conclude, basically, the our study evaluates how LSTM and GRU uh, models perform on the price predictions. The effects of the architecture, is architecture more important or the data representation is more important? So we took all this. In the stage one, GRU outperformed the LSTM and GRU's simpler architecture uh, have this. And in stage two, with 14 features and log return transformation improved, It's like feature engineering closes the gap between the model and ensemble modeling, improves the stability, reduce the variance across the LSTM and GRU outputs. Now let's move towards the future scope. In the future, we are planning to apply this framework to emerging cryptocurrencies like Polygon, Aptos, and longer term predictions. Like in this, we are doing 1 day predictions, next day prediction. But in future, we are planning that we can do weekly or monthly predictions also. And we are planning to have sentiment analysis also, like social media, the market hype. We can do sentiment analysis on that, and then uh, predict the movements of the Solana. And real-time learning also, like we can use towards some adaptive methods for the real-time training. Yeah. So thank you for your time and patience. Do you have any questions?
Thank you, Sonam. Sir, you can proceed with your questions.
Yeah, okay. Sonam, that was a very good presentation. Really an interesting topic for me. Just two questions I have. The first one
Yes.
is that why did you choose moving average, RSI, and MACD specifically, not any other parameters for evaluation?
Sir, I use moving average, like moving average basically smoothens the uh, smoothens the that like there are huge fluctuations, like they are non-linear. So it smoothed and averaged the basic that line. Like we used moving average of 7 days and 21 days, so that it stabilizes the output. And relative strength indicators is our moment indicators. Like if we take a range of 1 to 100, then if it is more than 70, then the cryptocurrency is overbought. And if it is less than 30, then it is oversold. Then we will use these technical indicators to have the returns on that day.
Okay, so can we implement the same framework with transformer-based or attention-driven models?
Transform based.
Yeah, transformer-based or attention-driven models. Can we implement the same system?
Yeah, we can use that, but it will add up to the like model complexity. Like if we use Solana, it has less data. So
Oh,
these models were more appropriate rather than transformer.
all right. So in future, can we implement a framework for real-time trading or risk management systems?
Yeah, we will work on that. Like we will research and explore how can we implement that in real time. Like
All right. Really good presentation. Thank you very much. That's it from my side.
thank you.
Okay, thank you, Sonam. For the next presentation, I would like to call Mayuri for the paper title Agritech Hybrid AI, Intelligent Plant Disease Classification and Adaptive Treatment Recommendation. I kindly request the presenter to start with the presentation.
Yes, 1 minute.
Yes. And it's humble request to complete your presentation within the span of 8 to 10 minutes. Please don't exceed that.
Can you accept my request?
There's no request. And I've enabled everyone to share the
Okay, okay,
screen.
okay. Good afternoon, everyone. I am referred from Vishwakarma Institute of Information Technology, Pune. Today, I am presenting our work titled Agritech Hybrid AI, which is an intelligent plant disease classification and adaptive treatment recommendation. So, which has been carried out under the guidance of Dr. Chudavan Sukti sir. So, in this presentation, I will begin with an introduction to the problem, followed by a review of existing literature survey. Then I will explain an objective of our work. Then I will identify research gaps, and then our proposed AI-based system. So, let's move on to the introduction. So basically, agriculture plays a very important role in ensuring food security and supporting farmers, livelihoods. However, plant disease significantly reduce crop yield and farmer income, especially when early detection is not possible. Most of the farmers do not have timely access to expert consultation to address this issue. Our system uses artificial intelligence and deep learning to detect plant disease from leaf images and generative AI for treatment recommendation. The system also support multilingual support like languages like Hindi, Marathi, and English, and making it farmer friendly. So let's see the uh, research gap. So existing research shows that machine learning and deep learning techniques, especially CNN, are widely used for plant disease detection. Many studies have achieved good accuracy using image-based classification techniques. However, most of these systems are limited to disease classification and only disease classification, and they do not provide any treatment recommendation. Some recent work focuses on real-time disease detection and recommended system. These are the challenges such as limited data set, poor generalization, and high computational cost, and lack of multilingual support still exist. These limitations are highlighted through our project. Then So the main objective of our system are to develop an accurate deep learning model for plant disease detection and apply transfer learning using a efficient net V3 to improve model robustness through a data augmentation, to evaluate model performance using accuracy and loss curves, and provides an automated early disease detection system that support agriculture decision making. So these are the some research gaps like limited data set which is focused on specific crops, reducing model generalization. Many studies are sensitive to lightning and background changes, lowering real world performances. Um so the proposed system our proposed system integrates efficient net v3 model for plant disease classification with generative ai for treatment recommendation. The system operates in 5 stages. First one was data acquisition, second one was data pre-processing and splitting, third one was cnn model training, and fourth one was transfer learning, and fifth one was classification and pesticide recommendation mechanism. Uh, the diagram represents that the complete workflow of our uh, system like leaf images are provided as input and proceed using a trained deep learning model. Once the disease is detected, that output is passed to a recommended engine that suggests a suitable organic, inorganic, or AI recommended treatments. This is the transfer learning architecture. We use a efficient net B3 model, which is lightweight, yet powerful CNN network architecture. So transfer learning helps to reuse a pre-trained model weights, which significantly reduces training time and improves accuracy, especially when working with a limited agriculture data set. So here we can see the result and uh, training and validation accuracy of our model. Our model achieves 99.54% of training accuracy. Um, uh, this graph, this slide shows actual output of disease detection where the trained model correctly identifies the plant disease from leaf images and gives the um, result like which uh, like gives the best recommended treatment like organic or inorganic which you want to choose. If you want to choose organic, and you can go with organic. uh, So when compared with existing system, our approach offers higher accuracy, integrated treatment recommendation, multilingual support, and improved farmer usability, making it more suitable for real world and agricultural applications. So these are the some advantages and disadvantages of our system. The key advantage of our system includes early disease detection, adaptive and intelligent treatment suggestion, multilingual interface support, easy of use for farmers, and these are the some disadvantages like require internet access, depends on quality of data set. So, the in conclusion, we have proposed a hybrid AI based system that not only detects plant disease but also recommend effective treatment. The multilingual interface improves accessibility for farmers, and the integration of generative AI enhances decision making. Overall, this system contributes to a suitable agriculture and improves crop productivity. So in future, the system can be extended to include features such as animal detection, fire detection, to provide early warnings of fire incident in farms. Then mobile integration, making the system available through a mobile apps for easy access. These are the some references, and thank you so much. Uh, any questions?
Thank you, Mayuri. Sir, you can proceed with the questions.
Yeah, Mayur, that was a nice work from your side. So you are a PhD student or a MTech student?
BTech student.
Oh, very good work done, really. I have only two questions for you. Can you just tell me that why did you choose EfficientNet B3 over other opinion models?
Okay, so B3 is a deep learning model. Um,
So why
uh,
did you choose it? That's what my question is.
I chose EfficientNet B3 over simpler models because it provides better balance between accuracy and computational efficiency. Unlike basic CNNs are older architecture, and EfficientNet uses a compound scaling which optimally scales depth, width, and resolutions together. This allows model to extract a richer and more detailed features from plant leaf images.
Okay,
So
and what type of datasets did you use? It was a public or custom collected?
I use a public data set which is on Kaggle. Like the data set contains 87,000 plus images and 40 classes, which is on
Okay.
Kaggle.
Okay, so apart from that accuracy and loss that you have shown me, did you analyze your work on class size performance or confusion metrics?
Uh, yes, sir.
Okay, so what was the output? What did you analyze? What was the analysis of those performances?
Yes, fine tuning the model with region specific or market specific crop data. Like,
Oh, no issues. No, don't worry. Don't worry. It's not a beta guide. Don't worry. Right? Okay, it's done from my side. Thank you, Yuri. All the best.
thank you.
Okay, thank you, Mayuri. Can you please unshare your screen? So for the next presentation, I would like to call Anjali for the paper title An Offline AI-Driven Survey Automation Framework Using Tiny Boat and Progressive Web Apps. I kindly request the presenter to start with the presentation.
Yes, 1 minute only.
Yes.
Yes, good afternoon, all respected panel members. I am Anjali Mukade, and I also have my team member with me. Today, we will present our paper title name was an offline AI driven survey automation framework using TinyBird and progressive web. This works focus on solving survey automation problem in low connectivity and rural environment using offline AI. Now, moving on to the problem statement. Traditional survey systems depend heavily on internet connectivities and manual post processing. In rural or low network area, this leads to delay in data processing, human error in coding, open-ended response, and third one is the risk due to the cloud dependency. Our motivation was simple, and next our motivation is the motivation behind this work is to enable a real-time intelligence survey processing directly on the data connectivity device. By eliminating the constant internet dependency, survey operation become faster, more reliable, and everyone can operate it from a rural area also. Uh, Next is the proposed solution. To address this gap, we propose an first survey framework that combines progressive web app, which is also known as PWA, for offline data collections. Second is the TinyBird, a compact transformer model for on-device NLP. The system can work without internet, automatically classify open-ended responses, and also store data locally and sync later with connective when the connectivity returns. Moving on to the system architecture. The system architecture starts with the PWA frontend used by the enumerous for data collection. Second one is the pre-processing module, which uses for a clean and data preparation for the text input. The third one is the TinyBird interface engine perform on device classification. Fourth one is a validation modules which checks the confidence and allow the manual corrections. Then moving on to the why tiny birds will be explained by my teammate.
Yes. Hello, I am Sakshi. I will explain why we use TinyBird. This slide explains why we selected TinyBird for our framework. TinyBird is a compressed and optimized version of the original BERT model. It provides near state-of-the-art accuracy while significantly reducing model size and inference time. Because of its lightweight nature, it is well suited for edge devices and resource-constrained environments. This makes it ideal for deployment in field surveys where device may have limited computational power but still require fast and accurate text classification. Thus, TinyBot helps us achieve a balance between performance, efficiency, and practicality. Next slide, applications. This framework can be applied across multiple real-world domains. It can be used for academic research surveys to automate response classification and analysis. NGOs can use it during fieldwork for efficient data collection in remote areas. It is also useful in public health data collection, agricultural monitoring, census operations, and disaster response scenarios. Overall, our solution is suitable for any large-scale survey environment where traditional manual coding is slow and error-prone. To conclude, this work demonstrates that integrating AI with progressive web applications can significantly improve survey automation. Our framework enhances reliability, reduces manual post processing effort, and preserves data privacy. It also supports scalable deployment in real world environments where connectivity may be limited or unstable. Thus, the proposed approach offers a practical and efficient solution for modern large-scale service systems. Our future scope will be in the future, Several enhancements can further improve this framework. We plan to integrate federated learning to allow privacy preserving model updates across devices. We also aim to expand multilingual support to include more regional languages. Further optimization of in-browser model education will improve performance on low-end devices. Additionally, more secure offline storage mechanisms can be introduced to strengthen data protection. These improvements will increase both scalability and long-term usability of the system. Thank you.
Okay.
Thank you,
So
Sakshi.
yeah. So
Thank
Sakshi
you.
and Anli, that was a nice presentation. Just 2 to 3 questions. One thing is that how do you ensure the data security if you're talking about local storage and local synchronization? How do you ensure data security?
Sorry, sir.
Yeah,
We
I'm
can't
talking
hear you.
about. Yeah, fine. I'm saying that how did you ensure that the data is secure in terms of local storage and local synchronization? Am I audible?
Yes, sir.
Yeah.
We ensure data reliability and consistency during local storage and synchronization by using a combination of IndexedDB, which is a local storage, the base persistence, unique record identifiers, and controlled synchronization logic. This design
Uh,
generates that data collected offline is not lost, duplicated, or overwritten.
all right. So how did you assure that the index DB will support the reliability and fault tolerance?
Sorry, sir, I can't.
I'm saying that how did you assure that index DB supported reliability and fault tolerance in offline data storage?
Okay. Java-based backend services will help to store in to use IndexedDB to yeah, and it will supported validated, structured, and reliable data storage. So it will provide security for data storage.
Okay, fine. That's it from my side.
Okay, thank you, Akshi and Anjali. You can kindly unshare your presentation.
Thank you.
Thank you.
So for next presentation, I would like to call Palak for the paper title Enhanced Spatiotemporal Traffic Flow Prediction with Dynamic Attention and Multimodal Data Integration. I kindly request the presenter to start with the presentation. Palak, are you there in the meet?
Hi, am I audible?
Yes, you're audible.
Yeah. Good afternoon, everyone. The title of my presentation is Enhanced Spatial Temporal Traffic Flow Prediction with Dynamic Attention and Multimodal Data Integration. So, as we know, due to rapid urbanization and the growth of vehicle, a lot of traffic congestion in urban cities is being seen, due to which problems like increase in travel time, fuel consumption, and environmental pollution is observed. Um, the intelligent transportation system rely on accurate traffic flow prediction to predict the estimated time of arrival, etc. So, in the traffic flow prediction is a spatio-temporal forecasting problem which uses the data of historical traffic patterns, spatial road network dependencies, and external factors like weather and events. Now let's talk about the background. Uh, in the earlier traffic prediction models, the time series model was used. Recently, deep learning and graph-based models are used for traffic prediction. Real world data is often incomplete or noisy due to sensor failures or other external factors like events or some accident, etc. So there is an important need uh, for an accurate, computationally efficient, and robust to missing data types of models. So the system, the modern traffic system often faces challenges like non-linearity of data, time varying traffic patterns due to a lot of external factors, and spatial interdependency between the road segments. Uh, During a literature survey, we observed that in the old order traditional uh, models, issues like the data was linear and stationary, hence a dynamic data cannot be used. And as we as the time went forward, models like CNN and LSTM came. uh, there were some hybrid models which use this model, due to which spatial and long-term temporal features were solved, but still short-term fluctuations were seen. Then come the graph neural networks, where the issue was the high computational cost. It cost a lot of time if we use a graph neural network for traffic prediction. So, as a solution for that, GNN transformer hybrid models were achieved, but still they were sensitive to missing data. So, we identified the problems like high computational complexity, poor robustness, and a static attention mechanism fails under violated conditions. In real world, the traffic is affected by weather changes, accidents, road closure, or public event or emergencies. So the research gap was we needed a lightweight, robust, adaptive model, and we must integrate the spatial, temporal, and external information to get a practical, accurate data. So moving on to methodology, uh, we proposed that a model where the input was taken from the publicly available data of the major urban cities like California, Los Angeles, England, and Italy. And we used traffic network model as graph, where the nodes were the road segments and edges were the spatial relationships. Uh, So this is the proposed hybrid model which we proposed. First we input the data, and by using BGCI, we fix the data by preprocessing the missing values. Then we use CNN model, DSTM, dynamics spatiotemporal attention mechanism, which further for temporal modeling, we use GRU and by LSTM. And at the last, we get output in horizons. Horizons uh, are of three types, like they are a specific time interval in which we operate, which we uh, use to conduct our, which we use to obtain our results. So this is we use CNN model to extract spatial features from traffic data, and then we use GRU to capture short-term data. Uh, it is useful in dynamic data. Then by LSTM we use for long-term temporal dependencies, uh, and the attention mechanism was primarily used for important time periods or location, like at the time of Christmas the area around churches will be highly crowded. So for that we can use this mechanism, and uh, we use BGCI for handling the missing traffic data. And multimodal, by multimodal data fusion, we integrated the weather and event, or means real time issues to fix the data. So the data set we use, as can be seen, are PIMS, California, Los Angeles, UK, National, and Italy. So we used data of the 5 minute interval from each of these cities, which was publicly available on the data set on the internet. Uh, and the evaluation matrix we used were mean absolute error, root mean square error, and mean absolute percentage error. And the result we obtained was that the efficiency was great due to, as it was a lightweighted model of CNN and GRU. Also, the robustness increased because BGCI was very helpful in imputation in fixing the data, and also the peak performance increased due to the GNN transformer model we used. So, as a conclusion, we propose a hybrid model for spatial temporal prediction, which effectively captures spatial dependency, short term and long term temporal patterns, external influences. Also, as a future direction, we will try to develop a more lightweight model because we experience some difficulties while using this model. So we will try to make it more CNN graph hybrid model. That's all for my presentation. Thank you.
Okay, Palak, that was an interesting presentation. Just few questions from my side. Is
Yes.
it practically feasible to deploy this model in real time for Indian roads and Indian traffic?
No, sir. Actually, on public data, we didn't fetch the Indian data because this data is uses sensors on the road for fetching them. So we didn't get them.
No, but can it be implemented in real time for Indian traffic or Indian roads?
No, sir. It's still an issue. It wasn't as successful as that. Yeah.
Okay. So why did you use GRU and BIOS LSTM both? What was the reason for combining both of them?
Sir, because the Sir, because GRU in GRU it is used for short-term traffic changes, while BLSTM is used for daily and weekly periodic pattern predictions. So it so by using them both, we fix this short-term and long-term traffic prediction issues.
Okay, so considering rapidly changing traffic conditions, right? The traffic
Yeah.
changes rapidly. So how do you say that the dynamic spatiotemporal attention mechanism will improve adaptability of traffic?
Sorry, sir, can you repeat the question?
Considering the rapid changing of traffic conditions, right? How can you say
Yeah.
that the dynamic spatiotemporal attention mechanism will improve the adaptability of the traffic conditions?
Um, Sir, DSTM, it identifies important road segments and critical time intervals like some of the holidays and all. And in that way, it studies the pattern and helps in predicting the data accurately.
Fine, that's it from my side.
Thank you, sir.
Thank you, Palak. Can you please unshare? Okay. So for the next presentation, I would like to call Sohil for the paper title, Impact of Remote Work on Mental Wellbeing, a machine learning, clustering and explainable AI study using a synthetic workplace data set. I kindly request the presenter to proceed with the presentation.
Thank you, ma'am.
Yeah, you can start.
Yes, I'm sharing my screen. Yes, so good morning to the panel member for this presentation schedule, and good morning to other friends and colleagues. My paper title is Impact of Remote Work on Mental Well-being, a Machine Learning, Clustering, and Explainable AI Study using the Synthetic Workplace Dataset. Along with me, I have Mr. Mohit Singh Parmar, uh, is also present over here. And to begin with, this is the overall outline of the presentation of this paper, that is introduction and motivation, followed by problem statement up to the conclusion and the future work, followed by the references. So we know that after, especially the COVID, the remote work is a new normal for especially who are in the IT and the software development field. And even after the COVID went away, some companies still following the remote work architecture as a regular practice in their operations. But fundamentally, good companies, those who are concerned about the employees and the productivity and the efficiency and the impacts of this remote work, they wanted to study the the stress level employee have uh, due to the remote work, or the satisfaction and overall mental well-being, because in remote work, earlier the offline work has a time limit that after 9 or 10 p.m. the employee are supposed to go back to home, and there is no work. But in this remote work, almost any time any work may come. So naturally it affects the stress level of the employee, and sometimes it allow for a satisfaction, like because they are not supposed to work uh, when nothing is there. So it's a mixed kind of a feeling. So companies want us to study these impacts, and we have to do on a synthetic data, because the real employee mental health data is difficult to collect due to the privacy and ethical and legal concerns. So generally, researchers who are doing this kind of work in the mental well-being, they are using the synthetic data sets. Our objective is not here to improve the efficiency of the result, but our objective is here to see that the synthetic data contain a real useful pattern or not, or it is a simple random noise, right? So this is our major research problem, that uh, what to do in this thing. So the main problem is that the synthetic data set is uh, is good. Sometimes it appears realistic, but it does not preserve real correlations and dependency structures and meaningful machine learning prediction patterns. Because of this, what happens, even if the better or the best algorithms or the models will not work properly and will work poorly, and the clustering becomes weak, and overall, the if the research synthetic data is not proper, synthetic data is not as per the structure, then this kind of things may happen. Here our objective is to test the predictive ability using the machine learning models, verify the hidden groups if there are, validate the feature influencing using the explainable AI, and give recommendation for better correlation aware synthetic data set. So our contribution is basically focusing on, or has done on, developed three prolonged evaluation pipelines, which are supervised, unsupervised, and explainable check. found a data set shows near random performance and provide the best practices for correlation aware synthetic data set generation. We have done we have researched, we have reviewed some of the good papers where uh, 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 experienced researchers have focused on identifying the impacts of remote work outcomes, and some research was also focused on the synthetic data used in other domains like healthcare other than the mental health, and some even also focused on the synthetic data generation techniques in healthcare using various constraints. And fundamentally, good research papers are available, and good researchers are working on this aspect nowadays, because nowadays the companies are more concerned on the mental health part. So for this purpose, we have taken a Kaggle data set for the remote work and mental health. It has around 5,000 records and available in a tabular format like location, stress level, satisfaction, social isolation rating, sleep quality, hours worked per week, job role, and communication load, etc. So this was an overview of a data set. And why the synthetic data validation is required? Of course, we have discussed a lot, but the feature target dependency and joint distribution are missing in synthetic data set. And that's why the result or the performance of algorithms may be variable. So this is the proposed methodology where the data acquisition followed by feature selection, followed by encoding and normalization, then partitioning. Then, based on the model selected, whether it's the supervised or unsupervised, the model evaluation happens and clustering analysis, followed by the explainable AI, which gives us the insights and conclusions. So, this is what I have just told. A supervised model in which we have used the logistic regression, random forest, SVM, XGBoost, and Keras neural network, where the 80% data was used for training and 20% test data was used for testing purpose. And the metrics which were used was the accuracy and recall and F1. Similarly, the neural network architecture was used where the input dense 64 ReLU, dense 32 ReLU, output dense was 3 softmax, and the training setup was epochs was 25 and batch size was 32. And the supervised learning results are shown on the screen. Of course, the accuracy is not so much because we are not focused on the accuracy part. That's why the accuracy is around 33% to 38%. Uh, Similarly, the random baseline expectancy accuracy was around 33%. So overall, irrespective of whichever method is used, we have achieved the accuracy of 33%. And the explainable AI as explains that uh, the features influencing the prediction and the magnitude of impact. So if a data set contains a signal, then SAP importance will be stable and meaningful, and vice versa. These are some SAP interpretations graph and their values according to different class. So overall, even if even if the synthetic data set looks realistic, but sometimes it fails in prediction and clustering validity and explainability stability because it is not having the dependency part. Proposed pipeline or model offers a reusable framework to test a synthetic data set utility before using it in a real world. And of course, it is helping in HR analytics and mental health prediction tools and privacy sensitive ML research, and so many applications are there. Our research is in a primary stage, so later on we can have more stronger outcomes, and I welcome suggestions from the panel member for this presentation. Thank you.
Very good presentation, sir. That was a
Thank you, sir.
really good presentation. Just one or two questions from my side. Have you tested the data with the real-time patterns that they contain?
Sir, our objective was actually not to test the data for the real time part. We were actually
Okay.
looking that the synthetic data is how much sometimes becomes misleading, and the researcher start understanding they have got a very good result, but sometimes they miss the important dependency factor in a synthetic data, especially in healthcare or mental health care. I realized, and my teammate also realized, that you cannot go with a synthetic data results or model to prove something.
Okay. So, why did you combine all three different techniques, classification, clustering, as well as SHAP?
Sir, actually, I am the co-author of this article, and I would like to just add on to your question. That, sir, actually, it
Yes.
is a part of the major research. Actually, we are working on the mental health prediction problem, and in that, we got
Okay.
a comment for this particular task that from our DPC member. So, we are working to prove that that synthetic data set, even in the supervised learning and supervised learning, it is not having that much potential because we have collected the data set from the real world, but the data size batch is a little bit limited. As you know that it is quite difficult when we talk about the mental health data set, so people are having the security issues. So that's why we are just defining the comments that we have taken, and then to
Okay.
this particular question we have done these three techniques, and now we'll propose in such a way to have our major research problem. That's how we have just defended the comment for the synthetic data and the collected data that we have. Now we can work on that particular comment. That's why we have done this approach.
Fine. So, really nice work, both of you.
Thank you,
Thank you
sir.
very much. That is from my side.
Thank you, panel member, and thank you, the organizer. Have a nice day ahead.
Okay, thank you, Sohil. So for the next presentation, I would like to call Bharti for the paper title Machine Learning Approaches for Correlation Analysis of Aracanut Fruit Rot Disease Intensity with Weather Parameters. I kindly request the presenter to start with the presentation.
Good afternoon to all. Myself Bharati K, research scholar in Nitte University, and I am doing this research work under the guidance of Ashwini B. And my title is Machine Learning Approaches for Correlation Analysis for Aracanut Fruit Rot Disease Intensity with Weather Parameters. And aracanut is a major commercial crop in the Western Ghats of India. It providing livelihood support to thousands of farmers, but its productivity is severely affected by fruit rot disease caused mainly by Phytophthora species fungus. This disease is strongly influenced by weather factors such as rainfall, humidity, temperature, soil moisture, and wind. Traditional disease management practices are largely reactive and results in delayed control and economic losses. To address this, present study analyzes the relationship between weekly weather parameters and fruit rot disease intensity using machine learning models such as linear regression, random forest, gradient boosting, and voting regression. This results indicates the ensemble-based models outperformed compared to individual approaches, with the voting regression achieving the highest predictive accuracy. Okay, these are the objectives of my work. Analyze the correlation between weather parameters and disease intensity. This objective focuses on understanding how different weather variables influence fruit rot disease. And here, statistical correlation methods such as Pearson and Spearman correlations are used to quantify the strength and direction of relationship between disease intensity and weather parameters. And second objectives is based on based on this, multiple machine learning models are developed and compared to predict the disease intensity using historical weather data. Model performance is evaluated using the mean square error and R square score. And third objective aims to determine the most influential weather parameters contributing to disease occurrences. Feature selection techniques and model-based importance measures are applied to rank the predictors, identify these key features to enhance the model performance, and support the development of targeted early warning disease management systems. And based on this, I have collected the data set, that is weekly weather data, and disease intensity is collected across multiple locations and growing seasons from May to November. And weather parameters were obtained from CPCRI weather stations and on-field sensors. And disease intensity data were recorded through field observation and farmer survey. These are the features I have selected. Uh, Rainfall, humidity, soil temperature, water temperature, wind speed, and temperature. Okay, these are the features we have selected. And rainfall is above 25 degrees Celsius. Higher rainfall is strongly associated with the increased disease intensity. And humidity is, suppose if that is greater than 90 degrees Celsius, higher humidity also correlates with higher disease intensity. And soil temperature, here two types of soils and temperature is selected based on the depth, 5 centimeter and 10 centimeter. Again, suppose that is in between 25 to 30 degrees Celsius, uh, it will reduce the disease intensity. Again, water temperature is also selected from 25 to 30 degrees Celsius. Wind speed in between 10 to 25 kilometer per hour. It also contribute to disease spread. Along with that, daily temperature is taken, that is in between, minimum temperature is 21 to 28 degree centigrade. Again, this is suppose if you have the high temperature, it may reduce the disease intensity. And here I have designed the frameworks to calculate the disease intensity based on the conditions. Okay, here we have selected 5 conditions: high rainfall, that is combination of different parameters, high rainfall, moderate temperature, high humidity, ideal soil temperature, that is the favorable condition for that disease. Again, condition 2, moderate rainfall, low night temperature. It will leads to extend the wetness and increasing the risk. Condition 3, moderate rainfall, very high humidity throughout the day, ideal soil temperature. It may continuous moisture allows to maximum fungal growth. Again, condition 4 and condition 5 also selected in this particular framework. Wind spreads force, increasing the disease intensity, and fungal force to survive and spread. And based on the Pearson and Spearman correlation, I got these results. There is a strongest correlation between the rain and temperature, strong positive correlation between rain, and strong negative correlation between the temperature. And these are the key features I found to increase that disease intensity or in that risk. Along with that, we have the moderate correlation between humidity, wind speed, uh, again humidity in both the afternoon and forenoon humidity, again soil temperature, water temperature. All these are the key features for that to increase the disease intensity. And here we have selected four machine learning models. Under this, first one is the linear regression, assumes the linear relationship between weather parameters and disease intensity. It serves as a baseline model. Again, second model, random forest, it is ensemble of this decision tree that models nonlinear relationship relationship and interaction among the weather parameters. And third one is the gradient boosting, builds model sequentially high. Here, each new tree corrects the errors of the previous ones. Okay, this approach captures the complex patterns and find the weather disease relationship. And voting regression, it combines the multiple models, and this is the result I got. And based on these four models, I got the good accuracy and good result from this voting regression. There we have combined on previous three models. And key finding of this presentation or this work is humidity and rainfall are major disease drivers, and ensemble learning outperform the individual models, and voting regression provides the highest accuracy. And this is the conclusion. Machine learning models effectively predict fruit rot disease intensity. Ensemble models improve the forecasting reliability, useful for early warning and disease management systems. This is the future work. We can use the deep learning and IoT based systems and region specific adaptive models we can refer or we can design. And these are the different references I have referred in this particular paper. Thank you.
Okay, ma'am. So that was an interesting topic for discussion. One or two questions from my side. The first one is that which weather parameter influence the disease intensity the most, according to you?
Rainfall and humidity.
All right. And why did you use
rainfall, humidity, and temperature. Rainfall is having the positive correlation, and temperature is having the strong negative correlation.
Okay. And why did you use both Pearson as well as Spearman correlations?
To check the differences, how that weather parameters are related to the disease intensity. In both the measurements, I got the same type of results. I want to know whether that result is different from two. Okay, for that I have used both the coefficients.
Okay, so when we talk about ensemble models, what advantages do they provide?
There we are combining all the models. We have some drawback in the linear regression. Again, we have some drawback in the random forest. To avoid that in the ensemble model, I have combined the linear regression properties of the linear regression, random forest, and gradient boosting.
Okay, yeah, that's it from my side. Thank you.
Thank you, sir.
Okay, thank you, ma'am. Can you kindly unshare your presentation?
Yeah.
So for the next presentation, I would like to call Mahashri for the paper title PyroGuard MI Fire Accident Risk Prediction in Cracker Production using Machine Learning on Chemical and Environmental Data. I kindly request the presenter to start with the presentation. Mahashri, are you there?
Yeah, yes, I can.
Yeah.
Good afternoon, everyone. I'm Mahastri from St. Joseph College of Engineering in Chennai. Today, I am excited to share our project titled PyroGuard ML, which focuses on predicting fire accident risk in fireworks manufacturing using machine learning. As many of us know, fireworks manufacturing is a very sensitive and high-risk sector. Workers deal with explosive chemicals, manual mixings, and environmental conditions that is need to be just right. In India, the town of Sivahasi produces nearly 90% of all fireworks, but it has also experienced many tragic accidents over the years. These accidents are affect not just business but also workers, families, and local company. So improving safety here is extremely important. Right now, safety checks are done manually. Supervisors physically check the machine mixing ratios and the temperature or humidity in the facility. But these checks are not continuous, and by the time something looks wrong, it might already be too late. What's really missing is a predictive system. that can warn us before things reach dangerous point. We noticed that while industries like chemical plants and gas system use IoT and machine learning for safety, fireworks manufacturing has very little research in this direction. We did not find any work combines chemical data, environmental sensor, ML-based risk predictions, dashboard, and real-time alerts for the domain. That's gap we are try to fill. Our main goal, we are very clear, predict whether condition are safe, warning, or high risk. Combine chemical and environmental factors, monitor the environment continuously using IoT sensor, display everything in the dashboard and send alerts so action can be taken immediately. We have searched some papers. When we look related studies, we found that parameters like temperature, humidity, and static charge are directly linked to instability and explosions. Machine learning models generally perform better and simple rule-based system for the kind of prediction. However, no one can yet build as actual end-to-end ML IoT safety solution for fireworks, which makes our contribution unique. Our system works in 4 layers. First, IoT sensor continuously collects the data such as temperature, humidity, and static charge. Second, the data goes through pre-processing and then into the ML model, which classifies the risk level. Third, everything is shown dashboard, so supervisor can easily see what's happened. And finally, alerts are triggered via SMS, email, or alarms. If the risk across a certain threshold, the system can run locally or in the cloud-based deployment. Um, For our model, we used both chemical mixing data like oxidizer to fuel ratio and environmental readings. The model outputs one of 3 labels: safe, warning, or high risk. This multiple parameter setup reflects real world conditions much better than relying just one factor. We are test 4 different models like decision tree, random forest, SG boost, and artificial neural network. We trained them using a mix of historical accident data and simulated data. We evaluate them using accuracy, precision, um, recall, and the F1 score. The model that performed best was random forest, mainly because it handled nonlinear relationship well and uh, high recall for high risk cases, which is important for safety applications. Um, Random forest achieved the best overall accuracy and more importantly demonstrate high recall for high risk predictions. It handles non-linear relationship effectively, is uh, resistant to noise and reduce overfitting, making it well suited for real industrial deployment. Mm. The results were very encouraging. The system was able to detect high risk conditions early, especially in case where humidity dropped on certain chemical ratios were unsuitable. The dashboard gave supervisors better situational awareness and alerts helped them take action faster. Overall, the solution was also cost effective and scalable for smaller units, which is important because many fireworks manufacturing operator on tight budgets. Hmm. If deployed, this system can reduce the accidents, cut down manual inspections workload, and improve regulatory compliance. On social side, it helps protect workers, save lives, and reduce economic loss in place like Sivahasi, where thousands of families dependent on this industry. Of course, there are some limitations. Sensor noise can affect the accuracy. Offline functionality is still limited, and we don't yet monitor the human behavior, such as unsafe practices. Going forward, we have planned to add Edge AI for offline use, computer vision to detect unsafe behavior, and blockchain compliance tracking. The system also align well with the Industry 4.0 smart factory concepts. To sum up, Pyrogod ML shows that when we combine machine learning, IoT, and real-time dashboard, we can shift safety models. This approach can make fireworks manufacturing safer, more efficient, and more sustainability. Thank you, sir.
Okay, that was the next presentation. So just wanted to know that which sensor features were the most critical when you're talking about risk prediction?
Sir, can you repeat again?
Yeah, which sensor features were the most critical when we are discussing about risk prediction?
Uh, um, moisture sensor or and chemical sensors, sir, because chemical sensors different from one cracker to another cracker, so it is some critical, sir.
How early can your system issue warnings?
Sir,
How early can your system reliability issue the warnings about the problem?
um uh, uh, our system, some temperature is high, warning alarms via messages, SMS, sir.
Okay, fine. So that is from my side.
Yes, sir.
Thank you, ma'am. Can you please answer your presentation? So for the next presentation, I would like to call Prajwal Kumar for the paper titled Real-Time UAV Tracking Using 5G PRS for Urban Air Mobility. I kindly request the presenter to start with the presentation.
Hi ma'am, I am audible.
Yes, you're audible.
My name is Ujjwal Rachati from KL Technological University, Hubli. Today I project uh, explain about the title of real-time UAE tracking using 5G PRS for urban air mobility. Our problem statement is traditional GPS-based UAE tracking is unreliable in dense urban environment due to multiple path and the signal blockage, creating the need of for robust latency solution that leverage of 5G position reference signal to achieve sub-meter accuracy and ensure safe air mobility operations. Uh, Urban area mobility is considered the future of transportation in smart cities, enable aerial vehicles to transport goods and passenger across urban landscapes. However, challenges such as the dense buildings, narrower corridors, and electromagnetic interference make accurate tracking and navigation difficult. So, while GPS has been widely used, it suffers from reduced reliability in urban convenience. The introduction of 5G network with their dense deployment of base stations and advanced feature like PRS provide an opportunity to overcome these limitations. We have comparison of GPS and PRS. Why we use the PRS instead of GPS? There are some difference are there, and mostly we use this case in only GPS are outdoors navigation, drones mapping are only used, and the PRS are indoor, outdoor, IoT, autonomous vehicles, and smart factories. So you use the PRS instead of GPS for this problem statement. Our main objectives are modeling and characteristics of 5G PRS channel for aerial vehicles to find the optimal configuration of PRS parameters such as productivity and bandwidth and multiple patterns that provide the optimal balance among the tracking accuracy, network overhead, and UAE power consumption under the different operation scenarios. For instance, high-speed inspiration various long advanced mapping. The project aims to design a sensor fusion algorithm to integrate PRS-based observed time difference of arrival positioning with abnormal UAE sensors such as a barometer and IME to generate the robust, continuous, and high fidelity 3D track. To evaluate through the simulation the performance of proposed framework in the terms of positioning accuracy, latency, and reliability against the requirements of BOLOS flight and other UAE applications. And there are some motivations are here. Urban air mobility is also promising area addressing last mile delivery and demand passenger transport in urban environments. And the GPS system is not reliable for positioning in dense cities areas because of signal blocking and multiple introduction of high rise buildings. So you use the PRS 5G position reference signals. The proposed project will use the 5G PRS tracking system developed in MATLAB to demonstrate the truthworthy alternative to GPS in UAM. The project will go further to realize the dream of autonomous and efficient aerial mobility in the futures. We have taken the literature survey here. UAE tracking using 5G PRS, intelligence 5G aided UAE positioning using neural networks, urban air mobility of last mile transportation. So in this literature survey, we have that we have do these projects. And system architecture overview, we have take the four layers: infrastructure layer, signal layer, processing layer, applications layer. You use these six base stations. One base station reference stations and other base station is central coverage, and remaining four are east, north, south coverage. UAE specifications. There are three UAE specifications are there. Package delivery drones, air taxis, and grid maintenance. In the UAE one package delivery drones, the type is quadrilateral and mission to complex path with altitude change. This speed is 20 to 30 milli per seconds and altitude is 20 to 100 meters. And UAE to air taxis are the types are fixed wings and missions are long distance linear trajectory. Its speed is 40 to 60 meter per second and altitude is 100 to 200 meters. And third one is grade maintenance. This is also type of the quadrilateral and mission is system coverages and its speed is 15 to 25 meter per second and altitude is 30 to 80 meters. You have you've taken the methodology. Step one is PRS transmissions. Each GNB transmits unique PRS pattern signal recognition to nanoseconds accuracy, multiple frequency subcarriers for delivery. Step two is the signal receptions. UAE receives the composite signal from all GNBs. GNB means the base stations. Signals arrive in different times based on distance. Additional white Gaussian noise added. Step 3, TOE estimations. Time of arrival, cross corrections with expecting PRS pattern, peak detection for timing estimation, noise filtering and signal processing. The step 4 is TDO, time of difference arrival calculations. Select reference GNBs, calculate time of difference and convert distance into difference. Position estimation, solve the hyperbolic equation using spherical interactions. Least square optimization for best fit. 3D position calculation in the X, Y, Z coordinates. And tracking filters, we use the Kalmar filter with constant velocity model and the state vector. Processing noise for maneuver handling. Measurement update with the new position estimation. There are here result are there. In the top plot, the figure shows that the dashes line shows the ground truth path of the target, and yellow color is shows the tracked path, and the color curve represents the time difference of arrival. Hyperbolic lines used to estimate the target position at each time. And bottom three figures are shows that the 3D subplot shows the geometry between UAE and the target, including UAE positions, plot, uncertainty, ellipsoids. So this blue line shows that the accuracy. And overall, the figure demonstrates how multiple UAE collaborate using time difference of arrival to track to moving target in 2D and 3D space along with the estimation accuracy. And this result is the X coordinator which performs raw error is plus or minus 4 meter fluctuations. Tracked error is reduced to plus or 2 meters and stability is 50%. And the Y coordinates perform raw error is plus or minus 5 meter variations. Tracked error is stabilized to 2.5 meters and smoothing is significant noise reduction. The Z coordinator performs raw error plus or minus 8 meters. It is the highest variance and tracked error is reduced to plus or minus 4 meters. accuracy 50%. Our result is package delivery. The raw position error is 6 meter and tracked position error is 3.2 meters. The improvement is 46% and air taxis. Uh, and the raw position error is 4.3 meters and tracked position error is 2.1 meters. The improvement is 51%. Grid maintenance. Raw position error is 6.3 meters and tracked position error is 3.8 meter. Improvement is 40%. Overall average raw position error is 5.5 meters and tracked position error is 3 meters. Improvement is 45 percentage. And conclusion is the project successfully designed and validate a 5G PRS based system for high precision real-time UAV tracking in urban areas through a detailed MATLAB simulation that included realistic channels, models, and changing UAV path. The proposed framework used to time difference of arrival malfiltration combined with Kalman filter. This approach shows the strong sub-meter accuracy and generally optimized traditional GPS in tough urban conditions. The result confirmed that 5G cellular infrastructure can be used not just for communication but also as reliable low latency positioning network. This work lays the important foundation for supporting safe, efficient, and scalable urban air mobility operation. It opened the door next generation autonomous aerial system in smart cities. These are the future scopes, and you take the reference. Thank you. Any questions, sir?
Yeah, Ujjwal, that was a nice presentation and nice work actually.
Got
Few
it.
questions from my side. Just
Got
wanted
it.
to know that if we use this approach in dense urban UAV traffic, then will it be editable?
In the PRS position reference signal in dense area in multiple base stations are there, so you use the PRS instead of GPS.
Yeah, that is it. But if I implement this this in at our dense urban UAV traffic, then is it scalable?
Yes, sir.
Okay, and how sensitive is your system to UAV altitude variations?
Sir, in UAE, urban air mobility is the future transportation in smart cities. So the PRS shows the accurate position of the in the smart cities in urban area. Like many signals are blocked due to the buildings and multipath. So we use the HARC that uh, retransmit the signal. So.
Okay, so can this framework support real-time BVLOS UAV
Sir,
operations?
your audio is not okay.
I'm saying that can
Sir,
this
repeat
framework
once.
yeah, hello, am I audible?
Yes, sir, audible.
Yeah, I'm asking that can we implement this framework on real-time BVLOS UAV operations?
No, sir.
Okay, fine. That is from my side. Thank you.
Thank you, sir.
Thank you, Ujjwal. Can you please unshare your presentation?
Okay, ma'am.
So for the next presentation, I will like to call Ria for the paper title Strategic Artificial Intelligence and its Influence on Decision Making and Business Performance, a PLS SEM analysis. I kindly request the presenter to start with the presentation. Ria, are you there in the meet?
Yes, am I audible?
Yes, you're audible.
And my screen is visible?
Yes, it's visible.
Okay. Good afternoon, everyone. My name is Ria from Graphicera Data University. My paper title is Strategic Artificial Intelligence and its Influence on Decision Making and Business Performance, a PLS, SEM and analysis. Coming to the contents, these are the contents. Coming to the introduction part, AI means machines that can think and learn like humans. AI includes machine learning, deep learning, and neural networks. Today, AI is widely used in organizations to improve efficiency, decision making, and performance. However, many companies still struggle to use AI in a strategic way, especially for the decision making and performance improvement. So, this study focuses on how strategic use of AI improves decision quality and business performance. Moving to the next slide, these are the literature review. Hypothesis 1. There is a significant impact of strategic artificial intelligence on the quality of strategic decision making. Our first hypothesis says that AI has a strong impact on decision making quality. As previous study shows that AI helps managers analyze large amounts of data quickly and accurately. This makes decision faster, smarter, and more reliable. AI does not replace human. Instead, it supports manager by providing better insights. Hypothesis second, there is a significant impact of strategic AI on the business performance. As research shows that organizations using AI strategically perform better, AI improves productivity, innovation, and operational efficiency. It also helps companies gain a competitive advantage through data-driven decision. Moving to the next slide, hypothesis 3. There is a significant impact of decision-making quality on business performance. As the third hypothesis states that decision-making quality directly affects business performance, when decisions are timely, data-driven, and when planned, organizations perform better both financially and non-financially. Hypothesis 4, there is a significant impact of strategic decision-making quality mediates the relationship between strategic AI usage and business performance. As AI does not improve performance automatically, instead AI improves decision quality and better decision then leads to a higher business performance. So decision-making quality acts as a bridge between AI and performance. Moving to the next slide, this is the research methodology. This study is based on the primary data. We have collected the specifics from 108 employees and manager who uses AI systems at work using an online questionnaire. This data was analyzed using smart PLS software and a PLSM technique to test the reliability, validity, and relationship between the variables. The next, it is a conceptual model. This model shows the relationship between the strategic AI, business performance, and decision making. Strategic AI directly affects the business performance and also indirectly affects it through decision making quality. These are the data analysis. In this figure, the PLS result shows that both strategic AI and decision making quality significantly impact business performance. Decision making quality has a strong effect, while AI has a both direct and indirect effect on performance. This table shows the path coefficient results. The result shows that AI strongly improves decision-making quality. AI also directly improves business performance. Additionally, better decision-making significantly boosts business performance. Overall, AI and decision quality together plays a key role in improving organizational performance. Moving to the next slide, table 2 shows the validity and the reliability. The Cronbach alpha and average value meets the required standards, which means the results are trustworthy. And to conclude, this strategic AI significantly improved decision-making quality and business performance. Decision-making quality plays a crucial mediating role between the AI and the performance. Organization that uses AI strategically can achieve better results, innovation, and competitiveness. However, the study has a limitation such as a small sample size. In future, we can conclude more industries and additional factors like organizational culture and ethical AI. And these are my references. Thank you.
That was quite an interesting topic. One more question is there from my side, that what practical insights should managers take from your presentation, from your study?
Sir, I can't hear you properly. Can you repeat?
Yeah, I'm saying that. What practical insights should the managers take from your work?
Sir, as we use the multiple construct and mediating variable, so these are from the PLSM, they can take the major effects.
All right. And which AI dimension influence the most in performance?
So can you repeat?
Which AI dimension influence most in your performance?
So strategic AI.
Strategic AI. And was the sample size sufficient for your model?
Sir, as I already said in my presentation, that the sample size is not sufficient. This is the limitation of my presentation. in the future we can take the more sample size for better results.
Okay, fine. That's it from my side.
Thank you so much.
Thank you, Ria. Can you please unshare your presentation? So for the next presentation, I would like to call Siddharth for the paper titled Sustainability Reporting Practices of Indian Construction Firms, Gap Analysis and Reporting Framework. I kindly request the presenter to start with the presentation.
Thank you, ma'am.
Yeah, you can share your. Yes, it's visible.
Good afternoon, all. Today, my topic is sustainable reporting practices of Indian construction firms and gap analysis and report framing. This is my review paper data. These are my guides, Hiral Patel and Komal Mehta. Background, background and motivation. These are the things which motivate me to take this uh, take this topic. Construction sectors drives India's growth, but has high high ESG impacts. It is environmental, social, and governance impacts. Uh, Resigning global focus on sustainability and transparency. ESG and sustainability reporting now critical for accounting. Indian construction reporting remains fragmented. Regulatory context. SCBI's business responsibilities and sustainability reporting, BRSI. This is the regular context which I have used mandatory for top 1000 listed companies since 2023. Elements pressure with global framework. These are the global tools, frameworks which are used for sustainability reporting, GRI, SA, SASB, and iOS. Implementations challenges remains. In India, implementation of these frameworks is a major challenge here right now. Why construction needs sector and specific reporting, project-based and non-uniform impacts, heavy reliance on subcontractors. In India, we are very reliable on subcontractors and material intensive and high labor and safety risks. In India, safety and labor safety are very compromised due to lack of their performance. Research objectives. Review sustainability practices in Indian constructions, benchmark practices against global standards, identify key gaps and challenges, propose a sector-specific reporting framework. These are my objectives. By this, I will review my topic, methodology, systematic literature review from 2020, peer review and industry thematic and comparative context analysis. These are my methodologies. Key literature instincts, reporting increasing by fragmented, large firms disclose more than SMIS. Generic frameworks lack construction specificity and limited imperial advice on reporting outcomes. These are my key literature instincts. As I as I mentioned earlier, there are three major impacts are which are used in this Indian construction: environment, social, and governance. Environment disclosure trends, energy and water use commonly reported. Carbon disclosure often incomplete. Embodies carbon rarely addressed, and waste material inconsistency. Social disclosures. Occupational health and safety commonly mentioned limited quantities, safety KPI, keep KPIs, labor's welfare, and mitigate labor issues under reported. Community engagement mostly descriptive. These are the social disclosures. Governance disclosures. Um, bo- Board structures and policies reported. Anti-corruption disclosures uneven. Limited third-party insurance. Governance quality linked to disclosure depth. These are the major gaps which I identify. Lack of sector-specific KPIs, weak supply chain and subcontract reporting, inconsistent materialistic assessment, limited data capacity, and essential, especially for SMEs. Proposed reporting framework, sector-specific ESG indicators, alignment with BRSD and global standards, tied with reporting for film size and capacity, clear KPI, efficiency and boundaries. These are the expected benefits which I which I will get from my research. Improved comparability and transparency, better policy compliance, enhance the stakeholders' trust, support India's sustainability and climate goals. Conclusion: sustainability reporting is improving but remains inconsistent. Sector-specific approach is essential for construction. Proposed framework bridges global standards and Indian realities. Collaborate efforts needs across stakeholders. Thank you.
Okay, Siddharth, that was an interesting topic. So, few questions from my side. Can you just tell me that how effective is BRSR for construction sector?
Sir, sorry, sir.
Yeah, how effective is BRSR for construction sector?
Sir, it is very effective, but not its application are not really good in India. It is very hard to implement.
Okay, so can you just differentiate large firms and SMEs based on reporting?
Sorry, sir.
How does reporting differ between large scale firms and SMEs?
Large scale firm.
Yeah, large firms and SMEs.
Sir, that I don't know about that.
Okay, so considering Indian reporting practices, what are the key gaps that we have?
We are facing knowledge and lack of the information gathering. Topic is very new in India. No very research are conducting right now. So lack of information and data collection is major
Okay,
lack.
fine. So that is from my side. Thank you, Siddharth.
Thank you.
Thank you, Siddharth. Can you please unshare your presentation? So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for support during this 10th version and all the previous 9th version of the conference. We will be happy to have you in 11th conference in 2027. All the presenter will be getting their digital certificate through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I also thank our session chair, Dr. Rachit Advaryu, for chairing the session. A token of appreciation to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Would you like to address the participants, sir?
Yeah, thank you very much for your gratitude. And I would just like to add one thing that all the presentations were really nice. The topics and the ideas and the innovations that they have presented was really interesting. So looking forward to serve as a associate more in your all upcoming conferences. Please give my regards to Amit Joshi, sir. Thank you.
Thank you, sir. Now I request all the participants to switch on their camera for a quick snapshot. Okay, thank you everyone.